This lesson we're going to be talking about the exponential function with base e. E is a rational number, similarly to pi, it's a number that never ends. E is approximately 2.71828182846 and so on and so forth. So this number powered by x. This number is larger than 1, so we are expecting the graph to be increasing. And this number is between the numbers 2 and 3, so the graph of e to the x is going to be somewhere between the graph of 2 to the x and 3 to the x. So if I'm gonna sketch the graph of 2 to the x, 2 to the x is gonna have the points for 0, it's 1, 2 to the 0 is 1, for 1 is 2 because 2 to the 1 is 2, for 2 to the 2 is 4. For 3 to the x, 3 powered by 0 is 1 again, 3 powered by 1 is 3, and 3 powered by 2 is 9. So I'm going to sketch those two graphs here. So that's going to be the graph of 2 to the x and the graph of 3 to the x is going to be somewhere right here. So we are expecting the graph of e to the x to be somewhere in between. What is the domain of this function? Again, the domain would be between negative infinity and infinity, and the range is going to be all positive numbers. And of course, there is a horizontal asymptote at the x-axis, which is the y is equal to 0. Next objective, we're going to be using the compound interest formula to calculate interest. Compound interest is interest that's computed on your original investment as well as on any accumulated interest. The model A, or the future value, accumulated value. So A, the accumulated value or the future value, is equal to the principal or the amount that is invested in the loan times 1 plus the interest rate converted to decimal divided by n. N is the number of times per year the money is compounded, powered by n times t. T is times in years, and n being how many times per year the account is compounded, n times t is a total amount of compounded period for the loan, for the amount of this interest, for the period of this interest. Another formula for compounding is the continuous compounding. This formula we use when we cannot say particularly how many times interest is compounded. It's rather compounded all the time. Again, the accumulated value is going to be equal to the principal times the number e powered by the rate times the time. Those two formulas are identical when n is infinity big number. When n approaches infinity, the formulas are identical. This first case we use usually for money, because all money questions are compounded per period of time. For example, when you buy a car, you pay interest every month, so 12 times per year, so n is equal to 12. If you invest in some bonds, depends on the way the bonds are set, they may be yearly, so n is equal to 1, or maybe twice per year, n is equal to 2. Well, the compound interest, or the continuously compounding, we use usually for natural examples. Bacteria grow, because bacteria doesn't grow twice per year or twice per hour. Bacteria grow all the time, so for continuous process, let's say bacteria. Of course, since that's educational material, we are going to solve questions like calculate compound interest that's compounded continuously, but that's not usually the case. So for example 6, suppose that you have $10,000 to invest. Which investment yields a greater return over 3 years, 9% compounded monthly or 8.75% compounded continuously? So the question here is about money invested, or the principal invested is $10,000. In the first case, the return is 3 years, that means the time is 3 years. 9% means the rate is equal to 9%, and we want to calculate this 9 in decimal, so 0.09. Monthly means that every month, or 12 times per year. And in that first situation, we're going to be using the formula A is equal to P 1 plus R divided by N powered by N times T. So the principal times 1 plus the rate divided by 12 powered by 12 times 3. Now I'm going to use my calculator later on to calculate that. Let's see the second case. The second case compounded continuously. Again, the principal is $10,000. The rate is 8.75%, which is 0.0875. Notice that n is not needed in this problem, because the formula is A is equal to the principal e powered by RT. It's continuously, so n is not related. Time again is 3 years. So in this case, the future value, accumulated value, is going to be 10,000 times e powered by 0.0875 times 3 years. I'm gonna have my calculator here to calculate those. So 10,000 times 1 plus the rate 0.09 divided by 12, and this is powered by 12 times 3. And it looks like after 3 years, a compounded monthly, the future value is going to be $13,086. $86.45. Compounded continuously, gonna have 10,000 times e powered by 0.0875 times 3. And compound it continuously, we are going to accumulate $12,982.28. So the question is, which one is the better deal? And of course, compounded monthly is going to yield more money. Pretty much the interest, when the interest is larger, even with a small fraction of decimal, it is way better deal to take the bigger interest versus how many times it's compounded. Next question. Find accumulated value of investment of $15,000 for 4 years at an interest rate of 6.5% if the money is compounded semi-annually, compounded quarterly, and compounded continuously. So again, we'll have principal to be $15,000 for 4 years. And the rate is going to be the same in all cases, 6.5%, which is 0.065. For question A, the accumulated value is going to be 15,000 times 1 plus the rate. For A, compounded semi-annually, what is N? N is how many times per year this interest is compounded. And since it's semi-annually, that means that there are 2 periods. So 15,000 1 plus 0.065 divided by 2 powered by 8. I shouldn't have had that. Alright, so it's gonna yield $19,373.66. For question B, we'll have A is equal to 15,000 times 1 plus 0.065 compounded quarterly. Well, how many quarters do we have? 4 quarters. That means divide by 4, power by 4 times 4. So let me see if I can change that. This case is gonna yield $19,413.34. And for C, I may have to squeeze a little bit here. For C, compounded continuously, I'm going to use a different formula. 15,000 times E powered by the rate times the time, so 4 times the rate, which is 0.606. I need to squeeze it a little bit more. Okay. 0, 6, 5, and that's 15,000 times e power by 4 times 0.065 e power by 4 times 0.065 okay, so okay, finally I got it. In this case, A is going to be 19,453 $453.95. So, of course, when the same condition, 6.5% for all three cases, as often as we compound, as better value we'll have for the investment. Example 8. In college, we study large volumes of information that unfortunately we do not often retain for very long. The function f of x is equal to 80 times e power by negative 0.5x plus 20 describes the percentage of information f of x that a particular person remembers x weeks after learning the information. Substitute 0 for x and without using a calculator find the percentage of information remembered at the moment of the first learning. Well, this is not hard to do because every number powered by 0 is equal to 1. So negative 0.5 times 0 plus 20, and e powered by 0 is 1, so f of 0, or at the first moment of learning, we remember 100% of the information. Substitute 2 for x to find the percentage of information that remains after 2 weeks. So after 2 weeks, we're going to need a calculator here. E powered by negative 0.5 times 2 plus 20. Well, this is the same as negative 0.5 times 2 is 1, so e powered by negative 1 plus 20. So 80 e powered by negative 1 plus 20. So it looks like after 2 weeks, we remember 49.43% of what we've learned, which is less than half. So if we don't repeat what we have learned at a particular moment, after 2 weeks, we only remember half of it. Find the percentage of information that remains after 16 weeks. Well, here we're going to do f of 16, which is 80 times e powered by negative 0.5 times 16 plus 20, and times e powered by negative 0.5 e powered by negative 0.5 times, okay, let's start over. 80 times e powered by negative 0.5 powered by 16. Let's start over. 80 times e powered by negative 0.5 powered by 16 plus 20. Okay, better. So it looks like after 16 weeks, we only remember 20% of what we have learned. And with this, I'm gonna finish this video.